Today seems like a good day for a code review. It's been a while since I've done a code review, sorry about that. The code I'm looking at today was submitted by Nikhil. It's publicly available on GitHub and I will put a link in the description. Now to the code. Now the idea with this code is that we want to time a bunch of sorting algorithms. So as you may all know, or as you will eventually find out if you stay in the computing field long enough, there are a lot of different ways to sort an array of objects, and some are faster than others. So I'm not going to talk about the details of the individual algorithms today. If that's something that you'd like to see in a future video, please let me know. But today I want to focus on a specific issue that Nikhil was having. You see, he has these 5 different sorting algorithms, and he's doing basically the same thing with each algorithm. So naturally, he wants to have some general code that handles each one. He just wasn't sure how to do it. So let's see what we can do with it. So down here in main, let's see what he's doing. First thing, I see some variables. Looks like he has individual runtime variables for each algorithm, begin and end variables. Those are going to be used by clock, and a file where he's going to write the results. The program takes 1 argument. If it's provided, it tells me how many integers to put in the array that we want to sort. We're going to be sorting random integers. And if I leave it out, it defaults to this size variable, which up at the top was initialized to 32. Then we're allocating an array for the numbers, and we open the file for the results. Then for each sorting algorithm, the program does basically the same thing. It gets a copy of the original array to make sure that every algorithm is working with the same random set of integers. That's important. It gets the time before the function runs, then it gets the time after the function runs. It calls this getSeconds function, which I'm guessing takes begin and end and subtracts them and converts the number of clock ticks to seconds, and then it prints out the time. So this is all pretty straightforward. Also, if this is your first time looking at timing code, I did another video on the subject a while back. I'll put a link in the description. Check it out if you want more on that. But the issue we're looking at here is that there is a lot of code repetition, and that was Nikhil's main concern, and it gives us a nice opportunity to try to dry up this code. Now, if you haven't heard that term used among programmers, dry stands for don't repeat yourself. It's not a 100% hard, fast, always follow rule, but generally speaking, if you find yourself repeating a lot of code in your programs, you should really be trying to generalize your code a bit better, and that's definitely the case here. Also, down below here, and we have a few functions that we've seen called above. There's fill random. This is just fills an array with random integers. getSeconds, just as I expected, this subtracts the start and end times and converts to seconds. Then there's getCopy. It reallocs an array pointed to by a static variable and then copies its elements. And I'm going to leave this for now. I have some concerns about this code. We'll come back to it because right now it's probably going to work just fine, but I'm going to want to fix it later. And then there's this print array. It looks like this function prints an array, and I don't remember this being called up above, so I'm not going to do anything with this right now, but we're going to keep an eye out for it. And if I compile it and run it, you can see that it seems to work. I can try a few different array sizes and different timings. Now, the main issue with generalizing this program is that the sorting functions aren't called the same way. The first 3 take an array and its length. The last 2, merge sort and quick sort, take an array and a start and end position. So to make these more generalizable, we've got to decide on one. I'm going to go with the first interface. That's just basically an array and its length because I think it will work for all of them with some minor tweaks. And then I'm going to define a function pointer type that looks like these functions. So let's call it sortfunc_t. And any sortfunc_t is just going to take an int pointer and an int, which is the length of the array. And then, of course, we need to change merge sort and quick sort so that they fit this new interface. So let's go and take a look at these functions. With both merge sort and quick sort, the reason that the interface is different is because these functions are both recursive, and this 3-argument style supports the kind of recursion we want. But it makes things difficult in main, so I'm going to rename this merge sort function to be merge sort internal. This will not be called by the user, but just internally. And then I'm going to make another merge sort function that has the interface we want, just the 2 arguments, and then this function will call the internal one. Easy enough. Now let's do the same thing with quick sort. We'll make the original version, an internal version, and then we'll make a new version that calls it. Now, at this point, someone's bound to say, but wait a minute, the point is to time these functions and you just added an additional function call which will slow them down. And yes, I did. And I don't think it will matter. A single function call is really fast, and anyone who is racing sorting functions against each other is probably most interested in how the timing changes as the size of the array that you're sorting scales. So as this array gets bigger, the impact of this little function call isn't going to matter all that much. So I'm not going to worry about a nanosecond here and there. I think the tiny delay really isn't going to matter, and the benefits we get from being able to generalize this code, I think, are far more significant. Of course, you're free to disagree. For convenience, I'm also going to define a struct that is going to keep track of the information for each sorting algorithm. Really, this is just a pointer to the function and the name of that function, and we'll call it sortfuncInfo_t. Okay, now let's go back to main and see what we can do with our code now that our functions all look the same. So first, I'm going to declare an array of those sortfuncInfoTs. This is going to be all my sorting functions because I just really want all of these things to be in an array that then I can run through in a loop. And I initialize my array of structs to contain all of my sorting functions and their names. And then, of course, I need to define this numFunctions variable just to keep track of how many functions I'm dealing with. And I'll come back to that later. But now let's come down and generalize this repetitive code down here. So let's make a for loop. That's going to go through my array one function at a time, and each time through, just do what we've been doing, but in a more compact general way. So we can move this code up into the loop. I'm going to move the copy function out of the timing because we don't really care how long it takes. We're really just interested in the sorting part. Then instead of bubble sort, let's call the appropriate sorting function for the location in the array that we're currently at. And now all this repetitive stuff down here can just go away. Of course, we now need to do something about all these individual variables. So let's make a times array to hold the times for each function. That's more general, and now we'll use that in our loop and make sure that we print out the right thing as well. And then down here where we write the results to the file, we need to generalize that as well. For that, we'll use another loop that goes through our times array and just prints out each of the times. Now, keep in mind that I could have put this logging code up in the loop that's timing the functions, but I think there's some value in separating the data gathering from the writing to the file. It's not a big deal, it's more a matter of taste, but for now, that's what I'm going to do. Okay, so let's try it out. And oh, it looks like I forgot to update the recursive calls in merge sort and quick sort to use the internal functions, so let's fix that. And it seems I forgot a variable when printing out the results. So let's fix that. And now we compile it and it runs. And now I'm going to change the output precision a bit because I'm seeing too many zeros. This is just my preference and it works. So our code still works, and as we're going, it keeps getting more general, so that's good. But it's not where I want it to be yet. Specifically, I'm not crazy about how I initialize my array up here. It's okay, I guess, but it's kind of long and it's still kind of repetitive. So let's change things up a bit and use some of the struct initialization syntax that C gives us. So this right here is much nicer. But now that I'm using struct initialization, we need to change up how we specify the length. So we make some minor adjustments. This still works. And now if I really want to go to the extreme and avoid repetition, now this might be a little bit excessive, but I can make a macro that will initialize the sorting function for me so that I don't have to write the name of the function twice. And rather than hard coding the array length, I can just use the compiler to help me out there using size of, just the size of the array divided by the size of the elements, and that should give me the length. And let's clean up a bit. I can remove these old commented out prototypes, and I can come down here and remove this print ARR function because it's not being called anywhere. Maybe Nikhil had plans for it, but I don't know where they were, and I generally don't like having code floating around that's never used. It just confuses things, so for now I'm going to remove it. Okay, now I also noticed that Nikhil included a test program that tests the sorting functions. Well, right now it just tests insertion sort. And I really like this. I wanted to draw some attention to it because I just love it when people actually include tests in their programs, because specifically we're focused on how fast these sorting functions work, but do we really care if they don't work correctly? So let's test them and make sure that the sorting functions actually work correctly. Okay, and there's that print array function again. Looks familiar, but here it is actually being used, so I'm going to leave it in. And let's just use the same initialization code we used in main over here to get an array of sorting functions. And let's generalize our testing code by copying the array, calling the ith sorting function, and then printing out the sorted contents of the array. And since the code is decrementing argc, Let's go through and just make sure that we're using n. And let's have the print array function print out the name of the sorting function as well. And I'll update that up top. And we compile, and oops, I need to update the printing of the original, and it also looks like I forgot to include string.c. And I have a seg fault. So let's look in our debugger really quick. I'm going to use LLDB for this. And let's print out I and look at that enormous value for I. That's not good. And let's look at size. Okay, the enormous value for I makes sense. Okay, that makes sense since I was passing the wrong variable into the function. So let's fix that. And now things make more sense, except that it's not printing out the function names anymore. How long has that been going on? How did I miss that? You know, don't tell me. Okay, so the problem is in the init sorter macro, I needed to add the hash symbol to tell it to actually use the name input as text. And we'll change that in both our tests and back in the main program. Now things are really working. Okay, so now I think we're getting close. I just want to come back to this getCopy function that I had some concerns about before. So far it seems to be working, as in we're getting the results we want, but there are definitely some things that I would like to change. The first thing is that I'm going to replace this for loop with a call to memcopy. Yeah, they both work, but I think this is going to be more readable. I mean, why reinvent a perfectly good function that does exactly the same thing? And we really should initialize this pointer. Up to this point, we've been getting lucky. This pointer is probably being set by the compiler to null at the beginning of the program, so things are working, but I like to initialize my variables explicitly. And of course, now I need to include string.h. Now things compile and they run just like they did before. So this cleaned up the function a bit, but now I'm really wondering if we even need this function at all, because we're really not getting any benefit from calling realloc on this array. I'm pretty sure that's just returning the pointer back to us each time because the size of the array is not changing. So the only benefit we're getting is the memcopy. So I'm just going to go back up into main and malloc the copy array once. And then each time through the loop, I'm just going to use memcopy to copy the original array into the copy, and so we get a fresh start each time. And this is really all we need. So this code is really functionally equivalent to what we had before, and it's a lot simpler, because now I can remove this function down below. And I think this is where I'm going to stop today. There are, of course, other modifications and improvements that I could make to this code, but this is all I have time for. I hope it was useful for you to see the changes that I did make and to see my thought process as I worked through the code. So thanks for watching. If you have code you'd like me to review, I'll put instructions on submitting code down in the description. It may take me a while to get to it, and of course I can't review all the code that you submit, but I'll do what I can. I look forward to doing more reviews in the future, and until the next video, I will see you later.